Hi students, welcome back to our video series on database management system, and our today's topic is decomposition and its properties. Okay, now what is decomposition? As the name indicate, decomposition means what? It is nothing but dividing. Okay, so if you have a table and you are dividing that table into smaller tables, okay, subparts, then that process is called as what? Decomposition. Okay, so decomposition means dividing a relation R into R1, R2, Rn. This is called as decomposition. Okay, there are two properties of decomposition. One is lossless decomposition, and the second one is dependency preserving decomposition. Okay, now what is lossless decomposition? Okay, here again, lossless means there should not be any loss. And what is loss? Loss of data. Okay, so if you are dividing any relation, any table, then there should not be loss of data. Okay, you have to make sure that there should not be any loss of data. And main thing is, when you combine the decomposed part or decomposed relation subparts, when you combine it, then you should get the your original relation back. Okay, so if I am dividing this R relation into R1, R2, if I combine R1 plus R2, then I should get what? Relation R. Okay, so there should not be any loss of data. This is what? Lossless decomposition. Okay, and there are certain rules for lossless decomposition. So what are the rules? Let's consider that you have a relation R and you are decomposing that relation R into R1 and R2. Okay, then the first rule is union of all attributes of both the subrelation R1 and R2 must contain all the attributes of original relation R. Okay, simply R1 union R2 should be equal to what? R. This is the first rule. Okay, R1 union R2 is equal to R. Second rule is R1 intersection R2 should not equal to phi. Okay, the intersection of attributes of both the subrelations R1 and R2 must not be null. This is the second rule for lossless decomposition. Okay, so there should be some attributes that are present in both R1 and R2. Clear? This is the second rule. Third is the intersection of attributes of both the subrelation R1 and R2 must be super key. So whatever output you are getting in intersection, okay, that should be what? A super key of R1 or R2 or both R1 and R2. Clear? It can be super key of either R1. If it is the super key of R1, then it is okay. If it is a super key of R2, then also it is fine. If it is a super key of both R1 and R2, then it also good. Okay, but it should be super key. That is the mandatory. Okay, understood? So these are the three rules for satisfying the lossless decomposition. Understood? Okay, what is the first rule? First rule is you need to find the R1 union R2. When you combine R1 union R2, combine R1 and R2, you should get what? Relation R. Okay, second is you need to find R1 intersection R2, and it should not be phi. Okay, phi means null. It should not be null. There should be at least one attribute in the intersection. Okay, and whatever output you are getting as the intersection, whatever attribute you are getting as the intersection, that attribute should be the super key of either R1 or R2, or it can be both R1 and R2. Understood? Now we'll take one example here. A relation R, A, B, C, D. These are the attributes of relation R. Okay, with functional dependencies as A goes to BC. That means A is deriving BC, or BC can be derived from A, is decomposed into relations are given as R1 is ABC. Okay, we are dividing this relation R1 R into relation R1 ABC and R2 AD. Okay, these are the two decomposition of relation R. This is lossless join. Okay, now we have to follow the rules. First rule is R1 union R2. So we'll calculate R1 union R2. It will be A, B, C, and D. Okay, R1 union R2 is equal to A, B, C, D, which is nothing but your relation R. So first condition satisfied here. Okay. Now second condition is we need to calculate R1 intersection R2. So R1 intersection R2 is, intersection is A. Here we have A, here also we have A. So intersection is A. Out result R1 intersection R2 is equal to A. Now we need to check whether A is the key, super key for any of the relation. Okay, so if we see R1, okay, we can derive from A, we can derive BC. Okay, and super key is the key using which you can derive all the attributes of the table, that is the super key. Okay, so here we have A, B, C, and using this A we can derive BC. That means we are deriving all the attributes of the table, correct? So A is the super key for relation R1. Yes, so here this condition is satisfied. Understood? So this is the lossless joint decomposition. Okay, clear what is the lossless joint decomposition? It is very simple. You just have to check for three rules. First rule is you need to check for union. When you combine both the relation, you should get the entire relation, your original relation R. Okay, then you have to check for intersection R1 intersection R2. There, this should not be null. Okay, and whatever result you are getting as intersection, that attribute should be the super key for any of the relation, either R1 or R2 or the R. Okay, so here we are getting intersection as A, and A is super key for R1 because on the basis of this functional dependency it is given that A can derive BC. Okay, and here we have only three attributes, so here we are deriving all the three attributes A, B, and C, correct? So this is my super key. So here we prove that this decomposition is lossless decomposition. Understood? Okay. Now next is dependency preserving decomposition. Dependency preserving means what? Okay, so whatever dependencies are given, functional dependencies like this, okay, whatever functional dependencies are given, that should be preserved by the decomposed relation. Okay, this is the purpose of dependency preserving. Okay, first is it is an important constraint of database. Okay, dependency should be preserved in every relation. This is the important concept. In dependency preservation, at least one decomposed table must satisfy every dependency. Okay, must satisfy every dependencies. If a relation R is decomposed into relation R1 and R2, then the dependencies of R either must be part of R1 or R2, or must be derived from the combination of functional dependencies of R1 and R2. Okay, so whatever dependencies are given, that should be satisfied by at least one decomposed table. Okay, so here I have taken for example, suppose there is a relation R A B C D with functional dependencies A B C. The relation R is decomposed as R1 ABC and R2 AD, which is dependency preserving. Why dependency preserving? Because we are having dependency A goes to BC, and this is satisfied by this relation R1, correct? So relation R1 is preserving this dependency, hence it is dependency preserving. Clear? Now example, one more example here I have taken. Consider relation as A, B, C, D are, okay, dependencies are given A to B and C to D. These are the dependencies which is decomposed into R1 AB and R2 CD. Okay, now, what we have to check whether this R1AB is satisfying the dependency. Yes, here A goes to B. This dependency is satisfied by relation R1. Correct? Now, here C goes to D. So, this dependency is satisfied by relation R2. Correct? So, here our relation R1 and R2 are satisfying the dependency given. So, we can say that this is our dependency preserving decomposition. Understood? So this is about the decomposition and the properties of decomposition. Clear? So I hope it is clear to everyone. If you have any doubt, any queries, you can ask in the comment box or you can meet me in the department. Okay, and okay, that's it for today. Thank you. Don't forget to hit the like button.